It's cold. Fitting an industrial grade inverter to my surface grinder, including fitting, wiring and programming. 2 parts. This is part 1. Maybe you watched the series where I reconditioned this Herbert Junior surface grinder Mark II. I've only got single phase in here, the motor's 3-phase, so I made a static converter to drive this, and it's in the base. Now people said perhaps I would have a problem because the phases on the motor would be unbalanced and I could get some kind of patterning effect on the grind. Well, I never really saw that, but unfortunately the static converter is not successful for other reasons, and the other reason is it doesn't have enough torque. So I'm fine in the summer when everything's warm and the belt is warm, but in the winter it's struggling to start with the static converter. It's not quite catching on. And I noticed when I was grinding something, even with a 1 thou grind on something 1/4 of an inch wide, it was inclined to stall. Luckily, as it turned out, I'd already bought an inverter to drive this, so when I was making the static converter I got to a point where I didn't think it was going to work. But I did in the end. And this just went on the shelf, standby. But now it's going to have to be fitted. Well, this is an IMO Jaguar Cub. It's rated at 1/2 horsepower, which is the rating of the motor. And looking at current capacity, this seems to have ample, probably double current capacity to drive that motor. I bought it second hand. I typically do, just to save money, to be honest, because I think there's nothing to be lost with the eBay guarantee. If it doesn't work, you can send it back. I've never had a problem using the eBay guarantee. And at the time I got it, I powered it on and the lights came on, but I've never actually used it to drive a motor. So I think that's going to be the next step. Connect this in and test it. I'll show you the problem. Now it's quite warm today. It might pick up, it might not. No, it's stalled, look. You hear it? No, if I keep trying this, it may work, but I don't want to damage anything. If that was the summer, that would start okay. The static converter is in a box in the base under here. That's the main switch, obviously, and the contactor is behind this plate. Now hopefully, as long as this works when I test it, I'm going to try and put that into here, make a carrier for it in some way or other. And if I can do that, then the whole wiring becomes quite simple because I can keep all the wiring within the body. But if I've got to mount this externally, and I suppose it would go on the wall if it didn't go in there, I'll have to bring out 3 sets of wires. So 1 wire controlling the motor, connected to the motor, 1 wire to the switches on the top of the column, and then another wire to power the lamp. The transformer for the lamp is inside here. Well, this is quite a nuisance, but it's all going to have to come apart. This is the 240 volt contactor that I bought. The blue wires connect to the motor, the red wires come from the switch below, the yellow wires are from the control switches on the column above. The static converter capacitors and the intelligent switch were in this box, and it took quite a bit of work to get this all to fit in here, but it's not reliable, so there's no going back now. It'll just have to come apart. Well, it's come alive. Now I don't know if this is going to turn the right way, so I'll turn that down 15, 16 hertz there. Oh, by good luck, it is turning the right way. Full speed, 50 hertz. Good. So the next step is to see whether or not this will fit into the pillar. These lines to the motor should be screened, and by rights the control lines here to the switches at the top also need to be screened. I think so. And if I make a carrier on these or something, that'll do very nicely. this way around I think will be better with the terminals at the back. And looking through my box of cable, I've just got enough of this screened for the motor. Well, I'm just looking to make some brackets the simplest way I can. So here's a cardboard template, which I hope will work with these bits of alloy sheet. Well, this paper template has turned into these. Now, as I was working on these, I thought that I'd got the shape wrong and I didn't think it was going to work. But with a little bit of fiddling, it's worked out fine. I'll just put a screw and a nut in each of these four corners on the inverter to hold it in place. That'll do nicely. Well, it's the next day and I've got those bits ordered, so a couple of meters of screened 4-core cable for the control for that inverter, and then a little box to put a relay in, which I'll need, and I will explain later. But I just thought I'd tell you about this. Now, it's easy for me to think, well, you've seen all this already, but not everybody's watched 280 something videos. So I'll just explain briefly. This was the static converter that I made and I put into the base. And I thought to myself, well, I've got most of the bits for this already. I won't buy an inverter. And I don't need speed control and I don't need reverse. So this will do. So I bought the box for it. Now, it didn't start quite like this. I had a couple of capacitors already, I think. One's the start capacitor, one's the run capacitor. And from what I'd seen online, all I needed was a 110 volt relay and a variable resistor. And that would do the switching for me, so that when, I won't get into all the detail, you'd need to look at the previous videos, but when the motor had started to a point, the relay would drop out and it would drop out the start capacitor and it would then run on the run capacitor, and that would be it. Well, I made that, but it proved to be very unreliable. Now, to cut a long story short, the reason it was unreliable was that this, I think it was the start capacitor, was leaky. Not the one I'm pointing to now, that was a replacement. But it took me forever to find out that it was leaky. And I had to buy a capacitance tester, and I already had a mega, so I could take it up to, say, 500 volts, whatever it was, and I found that it leaked. And because of the leakiness, the switching was unreliable. But I didn't find that till the end. What's that in there for? So I bought this, which is a voltage sensitive relay, the type of thing that you would see on an air conditioning unit. Not so much in the UK because we don't have them so much, but this relay came from the States. Oh, sorry, I've screwed that in the base there. You get the idea anyway. So I think that was about £45. So it started off with a project where I'd got all the bits almost. It was going to cost me nothing to do. And by the time I'd finished, I'd spent as much as an inverter. But anyway, in the summer, this worked okay. And I wanted to keep as much as I could of the original internals of the machine. Anyway, for the reasons that I've said, it's not worked out because it didn't have the torque. The motor didn't have the torque. And it doesn't like the cold, and the belt's very stiff when it's cold, and all of that. But that was the story of it. And it took me on and off about 2 weeks to get this thing working. And I was thoroughly frustrated with it by the end, but I thought I was okay, but not. But when you come back to revisit things, you see things that you should have done a different way. Now, for powering the light, the work light on this machine, I'm using an LED, and here's the LED driver. And I put these wires powering this directly onto the incoming main. Well, that's fused at 13 amps in a cartridge fuse in the plug, and we all know that can run to, say, 20 amps for a short period of time. Well, this ought to be fused typically at 6 amps, because it would be on a house lighting circuit. Now, I'd never put in a separate switch for this. It was wired straight across the mains. I'd always been a bit doubtful about that. So now's my opportunity. I'm going to put a fused switch outlet on the side of the machine, metal clad, and then we can switch this and fuse it separately. So that's worth doing anyway. Because of the way the inverter works, it can put high frequency electrical noise onto the output side, which feeds the motor. So to stop that electrical noise radiating, we should connect the motor with screen cable. Well, I have a bit here, it's just the right length. So we'll replace this blue with this. Now we've talked about the wiring to the motor, but what about the wiring within the motor? Now to use one of these inverter VFDs, you're going to have to set the motor to low voltage. So look on the motor plate and there'll be a high voltage rating, so many volts, so many amps. And for most motors, there'll also be a low voltage rating, so many volts, so many amps. So if the motor comes to you configured for high voltage, you'll have to change it to low voltage. And you'll see that on the terminal block, under the cover on the side of the motor, there will normally be 5 studs. 1, 2, 3, 4 and an earth. And if you can see wires coming out from inside the motor, and you can see this neutral stud connected to 3 coils, to wires going to 3 coils, then you know that it's configured for high voltage. And you need to change it to be this configuration. Now when you do that, don't reverse these coils. So leave that end on in each case and move that end to there and so on. If you reverse a coil, the current flows the other way, the magnetic field will be reversed, and that's not going to work. Now if you're lucky, the terminals will be labelled such as UVW, or maybe ABC, or maybe they won't be labelled at all. But there may be coloured wires coming out to this terminal block, and if you're lucky, all the wires will be a different colour, and if you're lucky, that manufacturer will have worked to a standard which you'll be able to look up. Or they might be labelled with little labels on the wires. If you're unlucky, well, then you're into guesswork almost. But follow that process that I said. Disconnect, move to there, and so on. Yeah, systematically. Now, occasionally, the motor's only rated for high voltage. It might be possible, if you take the motor apart, to find these ends of the coils that are fastened together, separate them and bring them out to the terminal block and configure it like that. But then, you know, that's getting quite tricky. I'd already wired my motor low voltage when I got the static converter, so I don't need to change that now. But just another thought comes to mind. These inverters pretty much all look the same. But actually they come in 3 kinds, and it would be quite easy if you were buying something second hand to get that wrong. So the inverter VFD drives can be single phase in, single phase out, 3 phase in, 3 phase out, or as we've got here, single phase in, 3 phase out. Now I've not really seen anything on eBay which is single in, single out, but I've seen a few 3 phase in, 3 phase out. So just be a little bit careful to make sure you're buying the right thing. The running current on this motor is only about 1.6 amps. One way of getting the sawdust off the bench. I looked online and the wisdom seems to be that you only earth one end of the braid, not both. And I think the logic is that you could get currents running around the braid. could have put those two together, couldn't I? Because they're going to the same place, but never mind. When we get a bit further on, I'll explain all about this for people who have not seen it before. But if you wanted to use this inverter with no remote controls, so in other words, start and stop by the front panel and speed control by the front panel, all you need to do is to put the supply in here. So earth, live, neutral, and then you put the motor on here, UVW, and that's it. And if the motor goes the wrong way, you just swap over any two connections. These connections here are for things like braking resistors, which we haven't got. And these terminals here are for the logic control. Now we're only going to be using start and stop basically forward. And so we'll connect to PLC, which is there. And we'll just connect to forward, which is there. Now there's a screw missing, that one, which is on 13. So 13, 11 and 12 are used for a variable resistor remote speed control, but I won't be using that. When I bought this inverter, that screw was stuck in there. If I found another screw, I could get that working, no problem. The terminal's slightly damaged, but it doesn't matter. Oh, and the other bit I'll need to tell you about is the programming, but we'll come to that. When I wired in the static converter, I put an LED on this front panel to show me when the start capacitor had dropped out. But now I want an indicator to tell me when the inverter has alarmed. I mean, if the machine stops running, is it because a wire's dropped off or something? Or has the inverter alarmed? Maybe due to overload. So I've got some little panel indicators. Now these I got from China, I think, through eBay. And they're really useful. You can get all sorts of different sizes, different colours, different voltages, and you can see these are 24 volt. And I've chosen those because the PLC connection on this inverter is 24 volts. Now this inverter comes with a quite handy little concise handbook, which you need to be a bit of a scientist to read and understand. It also comes in soft copy, so you can just download it anywhere, and it's much easier to search. Once you've figured it out, it's quite easy to wire these up. On this inverter we have this relay, 30A, B and C are the connections. 30C is common, and that relay can be controlled by something like up to 10 functions within this inverter. But the default function for this relay is it provides a no voltage alarm cutover switch. So if we pick up 24 volts from PLC, that one I think, and take it to one of the commons through this to the lamp, then that should give us an alarm indication on the front panel. Now we have to be able to test this. It's no good wiring it up if you haven't tested that that's what it does. And this inverter will take an external alarm trigger. You see these terminals, X1, X2, X3. Well, these are three multifunction inputs which can be configured for anything like up to 10 functions. I haven't counted it, but it's about that. And one of those functions can be external alarm trigger. That's the intention there is if there's something further down the circuit, like a programmable logic controller, and it errors and you want your inverter to stop the motor, then you would make that the input to here. So if I wire up one of these lamps, as we said, and I just take the wire on X1 down to up to PLC, I think, but if not, the other way around to common, and it should cause this to alarm, which should turn the light on. Then we will have tested it. Because this inverter has come to me used, I want to reset it to make sure everything's back at the factory settings. So we need to set H03 to 1 and then save it. So moving to H first of all, and that's H03. So I select it, and I want to set that to 1. Now for a factory reset, you have to press stop and button up, arrow up, and then you need to save it. So now everything is reset to the factory settings. I've chosen to use X3 as my external alarm feed, and for that to operate I need to set E03 to 9. Same routine, get to E03 to 9 and save, and return to main menu. So that the inverter will still operate, I've linked PLC plus 24 to X3, but if I take this off, the inverter alarms HO2, which is the external alarm trigger. Now I'm not quite sure how to reset this. It's only for my test anyway, but if I put that onto there, then maybe I can reset it. He says. This is where you blow everything up. Yes, and I've managed to reset that. If I take it off again, it'll trigger that external alarm. There we go. So when I wired up my light, I'll have that method to test that I've wired the light correctly across this relay. We don't get that much snow really. I think this will turn to rain soon. I've been trying to get back into the workshop. I've had too many other projects to do, as you may know. Well, with the weather being off, although it doesn't affect me too much really in here, but also the post being delayed. 3 things that were supposed to come yesterday, that's Saturday, won't now come till Monday. So it's making it a bit late for this week. Apologies.